think it's fine. All right, good morning, everyone. Thank you and welcome to Data Science Challenge, which is part of the IT Code Fair. And the theme for this year is, can machine learning predict IT project failures? This is a very interesting and challenging topic, and thanks Don and Ewan for suggesting this topic for us. So this event also coincides with the 10th year of the IT Code Fair. And for the Data Science Challenge itself, this is the third iteration of the competition. And it is the most competitive that we have so far. Okay, we have in total 11 teams. Previously, we had 5 teams in the first round of the competition. Then we had 3. This time we had 11. So because of that, we do need to keep to the time very strictly this time. So when the alarm rings later on, which I will explain, you need to stop talking so that we can complete all the presentation on time. So, but first of all, I'd like to acknowledge all First Nations people across the lands on which we live and work, and we pay our respects to elders both past and present. Now, this event will not happen without our esteemed panel of judges, and thank you so much for taking your time out of your busyness to be with us today. What makes this competition really valuable is because you will not be judged by your lecturers. You will be basically evaluated by people, experts from the industry. So first, I would like to acknowledge Ewan, Executive Director, Digital Government, who has been supportive of this event since its very beginning. Unfortunately, Ewan, due to other commitments, he will be evaluating your presentation through the recording later on. So I would like to also welcome Donald, Senior Director, Digital Strategy and Advisory from the NTG. Welcome, Donald. Why don't we give him a big round of applause? And we'd like to also welcome Brad. Sorry, I didn't put your name in, so didn't see it coming. So, but we are so excited for you to be here with us. Would you like to probably just let us know a little bit more of yourself?
I'm the manager of the data warehouse for education for the NT government. Work in the same department with these team as well. So my area is the technical kind of back end for data education.
That's great. Thank you, Brad. Then we have Ghazal, Senior Lecturer and Deputy Chair, Academic Board of the Faculty of Arts and Society at CDU. Welcome, Ghazal. And last but not the least, we have Liam from the Arnhem Land Progress Aboriginal Corporation, or ALPA. Welcome, Liam. So Liam is the D&A Solutions Architect with ALPA. And you will be judged according to the following criteria, according to your innovation, sophistication, the results, and the potential scalability and automation of your solution, as well as the quality of your presentation. There are a little bit of house rules to take note. So each team, as informed previously, you have 10 minutes to pitch your solutions, and followed by 5 minutes of Q&A. So in keeping with the schedule, an alarm will ring at the 10th minute and the 15th minute mark. So at the 10th minute, you should stop your pitching immediately, right? Even if you don't finish the slides, that's okay, right? And then it will be followed by 5 minutes Q&A, and then another alarm will ring, and then that will be the end of your session. And then we have to switch to another team. So in between, I will be assisting you to basically initiate the slides, okay, just to reduce any technical problem. Okay, so just let me do that in between the teams. So we will be selecting the 2 winners, first and second winners, okay, and they will be announced at the CDU IT Code Fair main event this Friday, at the DoubleTree by Hilton Hotel at Esplanade. So prizes will await the winners. But more than winning, what's really valuable is the fact that you challenge yourself to go beyond the classroom and to prove to the judges here that you can do some fantastic things. So lastly, here's the list of the programs. I'll be welcoming Dawn to just give a bit of motivation to everyone shortly. And then that will be followed by a list of presentation, 4G, followed by data enthusiasts, data lovers, data wizards, data science 4G, and then we have a short break, as well as a group photo session. So please do stay until at least the group photo session if you have presented this morning. And then there will be refreshment served at the time, and it will be followed by a second round of presentation by Insight Seeker, IT Ladies, Ray and Jack, Territory Data Solution, the Buffaloes, and finally the one. Okay. And in between, lunch will be served. You're free to grab the lunch. So I'm so sorry that we may not have a dedicated lunch session for judges. So feel free just to grab food as you watch the presentation. So we hope that we will end by 1 p.m. or even better, probably earlier. And finally, before I welcome Dawn, I'd like to acknowledge the sponsors for IT Code Fair, as well as Data Science Challenge, Northern Territory Government, NEC, MyTech, Larrikin, CDU, and so many other sponsors of this event. Thank you so much. So I'd like to invite Dawn just to give a short motivation talk.
All right, good morning, everybody, and thank you so much for your interest in participating in the Data Science Challenge this year. In coming up with the theme and the idea for the Data Science Challenge, we knew that AI and the use of artificial intelligence is something that is very exciting for the industry and is changing the way that people look at and view and use technology. In the NT government, we have been very, very lucky in that we haven't had a lot of large project failures that are very bad news stories for government when they happen. But they do happen, and it's really important for us to look for how to make an IT project successful, because when every dollar that the government spends, we are accountable to the people that vote in the government of the day for that, and IT projects typically cost a lot of money. So using AI in this new way to try and predict the indicators of success or failure of an IT project as early as possible means we can then learn those lessons and move that project into a state where it's more likely to succeed. And we're very excited as judges to hear about your ideas and what you've learned and what you'd like to present to us as a way forward using artificial intelligence. The panel of judges here, I know Jakob said that we are all professionals, and we definitely are, but we are very approachable. We are very much interested in your ideas. So be really clear, be concise, and don't be afraid of us. And we are not so professional that we can't be very personable as well. So please bring your excitement, bring your ideas. We're really looking forward to it. Thank you.
Thank you, Dan. So now we are ready for our first team to present. Are judges ready?
Yes.
Yes, okay, that's great. So the first presenter is the 4G. Right.
The first one.
Yeah.
No, that one. That's PowerPoint.
Just want to mention that.
Can you do
You can press
download it and do it full screen?
anytime you're ready.
Ready?
Ladies and gentlemen, welcome to our presentation today. We are Team 4G, stand for 4 glasses. So before we start the presentations, we would like to pay tribute to our First Nations people. and we respect the ownership of the land. So this is the outline of our presentation. The most important part is methodology, where we show how we do the project, and the evaluation and results, where we analyze the data and also give you some recommendations. Our objective of our presentation is to determine which is the indicators of the failure and the success of projects. In order to do that, we do some research, and we found out that there are 21 key features keep repeating of the research, and we collect the data based on those research, as you can see on the screen. So probably we can dig down into it in the later slides.
And next slide is the outlines of data collection and data processing workflows. First of all, we have to do the research to find many projects, and after that we have to find 36,000 projects to find the data. And the data is collecting from structured data is ready to use, and unstructured data is hard to use. But after that we have to use many methods. That's a beautiful soup or some kind like that. We have to grab in the data. After that we have to collect many research to figure out which is the successful projects and which is failure projects. And after that, we have to choose 21 feature that is significant one. And another, we have to collect significant 166 projects this year to certify the data set. And after that, we have to convert one data to CDU. And this is the sample unstructured data. We have to collect the data. It's in the test or in the website, and we have to collect this feature like project name and original budgets, and the last one is final cost, and to collect many data for the data set. And after that, we have to processing the data for visualization. This is the dashboard. We have to use this one, and we have to see is overall the data set. And after that, we have to use many tools to collect the data. And after that, we have to significant statistics. We have to show it on you guys. This is 166 IT projects with 83 failed project and 83 successful project from 20 countries. And this is 50 subcategory. And I acknowledge that 8% of missing value in data sets. We have to hard to use this one, but we have to commit this one. So to classify a project is failure or success, we use different algorithm from 4 different models, classification model. So we decided to use name-based model as our baseline model, and because the algorithm put in this model is simple, and also the result is provided quickly. And beside that, we have 3 different advanced classification model. So for extreme gradient boosting, its strength is to dealing with the high dimensional data, and for support vector machine, the strength is as it can dealing with the complex data and pattern. For random forest, it is useful for complex pattern and also handling missing data and noise in data. So as you can see from the left hand side, this is the diagram show how we train our model. So firstly, we load and clean all the data, and then extract all the feature that we want to evaluate. And then the data set then will be split into training sets, which include 80% of the data, and then the testing set including 20% of the data. So after training data, we have 4 metrics to evaluation each performance of each model. So the accuracy score, which measures the percentage of total project, including both failure and success, can be correctly identified. And the precision score is the measurement of how a success or failure project was truly labeled as success or failure. And the recall score
Recall score is to making sure that there is no missing project has been identified. And F1 score is the balance between precision score and recall score. It shows the overall performance of the model.
So after running through all the machine learning models, now we have a collection of different evaluation metrics of each model. As you can see from this table, so random forest has better performance with slightly higher evaluation metrics like accuracy, precision, recall, and F1 scores compared to other machine learning models. So we decided to choose random forest as the best model to predict whether an IT project is failed or successful. So to be more specific on how we run how we build the models, we first rank the features based on the importance of the features, and then we apply backward feature selection to choose the features, and we rebuild the models gradually. And after doing many experiments, we started with 21 features, and it went down to 5 most significant features, which are shown on the slide. They are user involvement, which is the level of involvement and engagement of end users during the project. The second feature is planning, which is the quality of project planning. The third one is changing requirements and specification. It shows how stable the project requirements and specification were during its life cycle. The fourth one is technical competence, which is the level of technical expertise of the project team. And finally is user satisfaction, which is the level of satisfaction of the end users with the final products and or services. So in conclusion, we chose random forest as the optimal machine learning model to predict whether an IT project is failed or successful. During the project, although we worked very hard, but there are still some limitations for this project. The first one is data collection. So as you know, much of the data is missing and uncollectible, and a lot of data are from like different sources. So it's pretty hard to scrape like all the data from one source. So we scrape the data from like some features from one source, and then we have kind of like manually collect the data in other sources as well to gather together and make a final version of dataset. And the second limitation is the definition, the diversity in the definition of success and failure, because there are a lot of different like versions on the internet and different ideas and opinions from different experts. So we need to define one that match the. We use the idea from the ICT report 2014 to define the success or failure. And next is tool utilization. So we employ web scraping and text processing algorithms, but with limited expertise. So at times, sometimes it doesn't yield the expected result. So it might lead to frequent manual data entry. So that's the the downside. And finally is the assumptions. So when executing the models, we had to treat all the features as independent features. And as a result, some features like budget, so it might influence others, such as the technical proficiency of the team by enabling the hiring of top-tier experts. And that also brings us to the end of our presentation today. And thank you all for listening.
Now, time for Q&A for the judges.
Great. I wanted to ask your team about how you went through the 21 measures of project success. What made you pick those 5 that you settled on?
So first we started, we ranked the importance of 21 features, and then we applied backward feature selection. So one by one, we every time we do experiment, we remove one feature out based on which is not a very important feature. So and then we do it like one by one until it went down to 5 most significant features with the highest performance. Yeah.
Having a look at your features, I noticed one was a feature that would only be available at the end of the project. Did you have any problems with data leakage with your process?
Sorry, can you rephrase
So one of your features is only available at the end of the project.
Which one?
That would be user satisfaction.
Here you can see in our list of data, user satisfaction here.
So if that wasn't available at the start of the project, how would you deal with that?
No.
In the 5. So I think.
Assuming the project we have to
So
apply
for
how to can use this feature to apply for the new project. And I think that's user satisfaction that is the list for the project apply. If you do this one, you have to know what is the important, and this is at the moment time. And you can use this for surveys and kind of that to get the information for this one first.
Actually, if you can see, like we have also have the user involvement during the project processing. So if the user have satisfaction at a level that's acceptable, so it could be like the determinant factor of the user satisfactions.
while running.
Yeah, while running the project. So that's why we have like the feature in the last one here. Yeah, user involvement. Yeah, with the project.
Fantastic presentation, well done. I just have a question. Out of 156 projects, which country, which project won? Which was the most successful?
We mostly collect it from three. No, I think this slide.
Not anti-government.
Yes.
So
82%
of
So
the
top
project,
three is
yeah.
like Australia, US, and UK, and also like some Asians probably. And it is from like major from a government project, so probably
From
we
different
can
countries.
do it. But mostly from Australia because there's availability of the information that we collected.
Which project was #1 in Australia?
It's
If you
Australia.
don't remember, it's okay.
I'm not sure because it's a lot.
Well, actually, we can use this interactive dashboard.
Yeah.
But we, so if you select like country Australia, and fail or successful, and then you can select like
So it's
government.
dashboard.
Yeah,
Yeah,
and
it
that's
show
what
up.
to
To apply
interact
for
with that.
dashboard, if
But
you
it-
have to go to deep inside the data, you just collect the filter, and after that you can solve all of this feature here, and you can see which is the feature that you need to look up.
Yeah. So we use Power BI to design this. So
I have two questions. One is in your model, is that the random forest is higher than the G-post. But typically, the G-post should be powerful than the random forest. Can you explain more? And the other one is if you use the G-post, how did you avoid the overfitting?
sorry.
How did you avoid the overfitting?
Overfitting.
The first question.
So the first question.
The first. Okay, could you repeat the first question?
The
Sorry.
first question is typically.
Normally,
Yeah.
random forest doesn't perform well compared to the XG boost
Yes,
machine.
yes. But in your model, it is that random forest is higher than the G-post.
So now we just first we run the baseline model, and then we divide the word into different parts, and then we align the different machine learning model for each member, and when we run the different machine learning models separately and with the same like process, and
So probably
So-
because of our data, because we have to manual a lot, and also like some data could be like different, so the data set could not like 100% reliable. So probably based on the particular data sets we run and we show this kind of results. So probably because of the data sets. But if we have more like resources and time to dig down on the data sets, probably it's more accuracy for the model running.
But
Yeah.
basically, when we have to do this three models, we have to the similar results. It's just not a bit different like this one. But when we have to take out of the features and some kind like that, the models is so different result. That is the thing we have to solve this one. But I think XGBoost or random forest is just about the result for the data set. When we have to change the data set, maybe the result will be changed. And after that, we have to get the limitation now. When we have to do the future, we have to collect more the data and more the projects. After that, we have to apply. This is reliable.
So basically, normally extreme gradient boosting will give a highest accuracy compared to the other three. But I believe that in each model will work differently in different data sets. So a more variability of data, and without with not too many missing data on it, so it will give the best result.
So for overfitting, we only.
Okay, thank you so much. The next group is the data enthusiast. Data enthusiast. Yep.
Good.
Oh, okay.
Let's duplicate.
Yeah. Sorry, just quickly.
Yeah. Good morning, everyone. So I come from data enthusiast, and here's my team member. There's one more, but she's not present today due to some her work. So yeah. Now I want to show you one figure. It's 4.5 trillion US dollars. Well, do you know what figures means for?
Is it project failure costs?
Kind of. It's close. So $4.5 trillion is the spending on the IT projects all over the world today. $4.5 trillion. And based on statistics, we have the spendings on the IT projects from 2010 to 2022. It increases over time from 3.1 and to the sorry. Yeah, it increased over time. So, and we have 66% of them are totally failure. So, how can we enhance? How can we improve them and not wasting money meaninglessly? So, basically, looking at the data set, we include 54 large-scale IT projects all over the world and 13 features characteristics to determine if a project is failed or successful one. So include 27 successful projects and 27 failed ones. So looking at 13 features characteristics, we have some basic information like how much is the initial budget for the project and which year does the project start to build, how much does the project cost overrun, how long is project forecast to be completed, how long does this project can overrun, which year is project launched, and from which does this project originate. That's the basic information all projects that we collected from. And the second type is the type of project. It is project governmental or non-governmental, and which domain does this project serve. So why we chose the feature government if this project is governmental or non-governmental, and basically based on the unlocking potential of public sector IT projects from McKinsey.com, we have 80% of the public projects that experience delay, but just 50% of them experience the same situation. And for the rate, we have the cost overrun, the public one or the governmental experience 3 times higher cost overrun for compared to the private ones or the non-governmental. So choosing the governmental or non-governmental project is really important feature to determine if a project is successful or fail. And some features for the real-time situation of a project, like what is the average GDP per capita of the project's countries during the time building the project. You know, economic situation really impacts the project's outcomes. Sometimes you can see that during the recession or the pandemic, all things, yes, some of the projects may successfully create a positive outcome, but mostly of them will be in a negative side. Or we have the average CPI of the project's country during the time building that project. And 2 more is any crisis event happening during the time building the project and happening after the project launched. So for the second feature here, it's not the thing that you see in the economic term. It's not consumer price index here, don't get me wrong. It is the corruption perception index. So the higher corruption, you know, many countries, most of the country with the highest power of economy, they have a better corruption cleansing. And looking at the top 3, one with the highest corruption index, like Denmark, Thailand, New Zealand, we can compare them the economy. So South Sudan, Syria, and Somalia, we can, yeah, so this is a really useful feature for us to determine if a project is successful or failed. And after running the algorithm, we chose the one named logistic regression. It gave me 81.81%. So that is our presentation. Thank you. Yeah.
In terms of the accuracy that you've got, were there any surprising things that you found during the project, like things that you're expecting to find versus what the data uncovered once you'd run through the with the algorithm with the data you had?
I think I haven't covered that because the target of this competition is to predict if a project is successful or failed. And anyway, this project is kind of on deadline for me. So yeah, I submitted it late, so I haven't found out any insights on that. But yeah, if we got time, I will do it.
Fantastic. Thank you for giving us insight into the environment as well as the project itself, but the environment. In terms of comparing different countries, when you compare different countries, in some countries you will have information available in English and data available in some others. So, did you experience any difficulties in obtaining data from different countries?
Yeah, it's a challenge. It's a challenge for us to get the data from many non-English speaking countries. But you know, we can translate it easily into English by many technology, advanced technology nowadays. So yeah, I think it's not a big deal anymore. Yeah.
Thank you.
Yeah. Thank you.
Did you have to manually manipulate the data much once you received it? So filling blank fields, that sort of thing.
Yes, mostly of the data we manually collected.
Yeah.
And I think, yeah, it's a minus point in our project, I know, but the point of collecting the data by manually, I think is kind of precise, and yeah, it's caused a lot of work. So I will find ways to collect it by scraping or automatic ways. Yeah.
The code you provided is only one algorithm. You try to use other algorithms for models.
Is the best one I found out. I also use the one like random forest or many kinds, but it is the best one. So we choose them to present to yeah to make to present it. Yeah. Thank you.
Thank you.
Thank you.
That's it. Thank you.
Up next, we have Data Lover. PowerPoint or PDF? PowerPoint.
Hi, good morning. Have everyone have coffee or tea? Hi, good morning. Our team name is Data Lover, and there is Nu, Tracy, and I'm Anna. So the content we are talking about, totally there's 5 parts. Firstly will be challenges understanding, pre-methodology, descriptive analysis, prediction model results, conclusion, and future work. So methodology, firstly, our team chose to use a cross-industry standard process for data mining. Firstly will be, we try to understand the objective of the project requirement. And next will be data understanding, data preparation, modeling, evaluation, and deployment. So the topic is about analysis of high-profile IT project failure and prediction. So research question that our team doing will be, are there patterns behind these failures? Can these failures be anticipated? And what does the data tell us? Challenges, I believe today we have the same challenges, is we have to manually collect all the data due to the data type in the different project in different country. The way they present and give to us is not the same type. So we have to manual and spend a lot of time for it. Also, not all the project we can access easily, especially if it's belong to the government, and some is due to the sensitive information. The access is prohibited, and we have to do a lot of Google search and try. Honestly, we have to ask AI to support in somehow to attract some data. Please note that the result for our group work is only based on whatever we can gather, the data that we achieve. So, and the solution, classification and filter of the data into the group that we think that this is a suitable feature that we can use for our project. Also, for an example, like country, project type, or project status. And pre-methodology, we will based on the value of the project, we will define that for the low level will be below $50 million value project, and the medium will be between $50 million to $500 million, and above that will be a high level project. Total, we have 18 features, which if we go by such as like country, by project status, also the duration of the project. So this is also quite challenging because some of project is tracked until now without a certain date. For an example, because the unforeseen COVID-19, there's caused delay, also a lack of the human resources or resources that required for the project itself. How are the project considered failures? There's many reasons, but we believe if it's falling into these, we will decide to group them in the fails project. Like if the project more extended period or having no finish date that I mentioned earlier, or over budget, no benefits, or not working well at the project objective, or doesn't meet requirements.
So next, I will talk about the descriptive analysis. Based on our data set we collected, we can see that 90% of total IT project had a result in the value, and major the project, nation, Australia, and USA is account for more than 25% of the total, and following the UK, Canada, and another country. Regarding the industry, we can see that 22% direct to government, and followed by the finance service, professional service, and transport, which represent 30% of the total IT project, and follow with the health service and common with 9% for the account. And it's consistently because with the funding source, because significant 67 of the total project have financed by the government. Regarding the budget, we can see that the significant 40% of the failed project lack the specific budget information. And follow it, 22% of the project falls into the medium budget, 50% with the high budget, and 30% with the low budget. Regarding the actual cost, we can see that 32% with the project failed with the medium budget, and follow with the similar grade 25% with the high actual cost and not specific. And you can see that with the completed IT project maybe on smart with the lower actual cost. In terms of the reason why the project failure, we can find that more than 75% with the reason poor of the project management and government, and maybe the same way 5% distributed by the external factor, resources management, and stakeholder engagement. And you also see that although some of the project completed, but we found that been also had a problem with the project management. We also run the correlation between the factor with the status, fail or complete the project, and we can find that with the actual cost, it's in the most crucial factor that had a positive influence to the status type, and followed by the nation budget and failure. Also the significant factor, but they had a negative impact to the status of the project. Conclusion for descriptive analysis, we can find 3 main points. IT projects are commonly implemented in the government, financial service, and professional service, as well as the transport industry. And IT project failure had the medium budget, also had the medium actual cost. That means around 50 million and 500 million cost. And IT project failure mainly by the poor project management, poor planning, poor controlling. Yeah, so next one we move to the model selection implementation, because the main objective of this project is predict the likelihood to the IT project failure. So we're gonna choose the most 5 popular classification model, which is logistic regression, decision tree, random forest, and KNN, and life-based.
Yeah, 2 more minutes.
Yes, and we have 18 features in the data set. So before deploy the model, so we need to choose the most important feature to put in the model. So we use the PCI to figure out most important feature is nation, industry, budget, actual cost, funding source, and failure types. So after that, we divide the data set into 2 parts, like training set and test set, with ratio 7:3. And after deploy the 5 model, so we can conclude the accuracy of 5 model. And as you can see in the table, so the decision tree model with highest accuracy rate, so we conclude is the best performance model for our data set. Inclusions, we can predict the likelihood of IT project failure, but the limitation in our project is the data set is limited, it's not really balanced, so it's not like perfect for the model. So the result only correct on chosen feature and our data set. And from that, so the further future work, we want to collect more data, add more valuable feature. So we want to figure out driving factor for good performance of the model. And also because we mainly like collect data manually, so we want to find the better way to collect the data. And we also want to combine the machine learning and deep learning model to resolve the overfitting of model, and we want to find the better data optimization. So that's our presentation. Yeah. And we have one question from us. So we wonder, so which measure to approve on high profile IT projects from the government? Because yeah, we find the rate for failure in IT projects very high. So I don't know like what's the main cause if they got approved and then they got failed after that.
Yeah, also because we come from different country,
Yeah.
the way we decide how to say this project is very different.
Yeah.
For example, in Singapore that I used to work with, the way they decide how to check failure is more than this, what I'm doing.
Yeah.
And also the project we're doing also related to the governments. So it's totally different, the way we decide and the way we work for the project also totally different from what I'm studying here also.
Yeah.
So we want to know like, how do you decide or how
Yeah.
do you think that it's failures? It's easier for us to understand, everyone here to understand too.
Yeah.
Yeah.
Look, thank you very much. I think that's a really informative project, and the time and effort that you put in thinking about this,
Yeah.
Yeah.
but then conveying it back, it was really well done.
Yeah.
And it is interesting, you're right, there are different ways that governments will decide to approve a project.
Yeah.
And then different ways government will talk about a project being a failed project or a successful project. But I think the metrics that you came up with and explained with are very much common across lots of governments, and I think you could take that forward, and if you worked with a client directly, the clients themselves might potentially work with you on those metrics and say, we want to focus on these metrics, and then take that data set and the methodology you've applied to come up with a model from there.
Yeah. Thank you.
The question that I did have, how big was your data set? Like, I don't necessarily need to know the actual.
Actually, we are manual gather for like 100 cases in different variety country. So, but because of limitation that I'm telling you, that even one of the project I remember is related to medical in the Queensland or some state in Australia, they lead me to a government website, which they ask me the login information, and I try and say, oh no. So there's the end up, we only can gather 81 cases. Yeah, it's not much, Because if we got more time to do more, maybe the result is different. It's of course it will be different. I'm sure, 100% sure. Yeah.
Great, thank you.
Yeah, welcome. Yeah.
So you've identified governance and project management were the biggest predictor of failure.
Yeah.
What exactly in governance and project management do you remember, or were you able to drill down or not really? Timeline, cost, budget management?
It's mainly cost management. It's mainly like cost management.
Cost management.
Yeah, because
It's- It's the fallen, I can say, is about project management skill, because the project management skill are a good person that I used to work with. They will pre-plan before the project with all the budgets, and right after that, after the tender and everything, they get rewarded. They need to reward for the budgets, human resources, also replan for, especially if involved the third party, for an example, vendor, or they might have a third party to provide, to supply the human resources, like for some expert or expert engineer. So they need to replan to get the lead time, to make sure that everything will be delivered in the correct time, also buffer for it. And the project manager is a good one. They will always work, and even they will run to the project. If anything happen, they will call different, or they also buffer different vendor. It's not only one vendor for the project. They need to use at least 3. So in case this one fails, we have another second, or we have the third one with the similar quality of, like, if, for an example, we have media converter to build up for different building or the time server. So we have to work at least with 3 vendors within different country. Because what if this country they fail in the production, in the lack of the chipset or whatever, then we still have another country. Yeah, this is how it's work. Yeah. Yeah, welcome.
Did you do any parameter tuning on the random forest model that you selected?
So can you repeat the question, please?
Did you do any parameter tuning on the random forest model?
Yeah, we have applied in Python. Yeah, so we just like apply the data set after we choose the most significant features. So we just apply in the model. Yes, and we find out the accuracy.
You do some fish engineering, like find the relationship between different variables.
Yeah, we use a heat map to find the correlation between the feature, and we use the PCA to choose the most like 6 important, yeah, and back yeah, and back forward. Yeah, thank you
so much.
Thank you so much.
Next, we can anticipate some magical moment with data wizards.
Hello everyone, we are Data Wizards and we are really happy to be here today attending 2023 IT Code Fair Data Science Challenge. And our project aims to predict IT project failure based on big data analytics approach. So let's first recap the challenge question. And stating the question, Australia's IT industry landscape has been marked by several significant failures as stated, and billions of money were wasted on that. So our project tried to identify the patterns behind that failure using a big data analytics predictive modeling technique, and try to identify the factor that play significant roles in the project management. And based on that, we try to predict the project outcome. And here are the table of contents today. And let's dive into the feature engineering part first. And we I will first explain the logic behind feature engineering. So we mainly use two methodology to engineer the feature. The first one, we're referring to the project management framework created by the Project Management Institute. Because as we know, a lot of projects, including IT projects in Australia, planned and implemented based on this. So across different stages of the project management and through across different area of knowledge, we can possibly find some valid and practical features. And the second one, we use the case study, and we dive into these 3 significant failures in Australia. So we are potentially to find very helpful features as well. And here are the feature lists. Those are the response variables, and among those responsible variables, time index and cost index are calculated based on the actual and estimated cost and time. And here are the exploratory variables, which are categorized into 5 parts, which could be better for analysis, also to monitor the project failure. And among those data, there are 2 types of data. First one is the ratio data, which is also known as continuous data, and the second type of data are ordinal data, and those ordinal data are on scale of 1 to 5, and we given based on this performance metrics. And now we will do the data set. I will explain the data set and do some statistical analysis based on that. Here's the data set overview, and here are the data set heading. We deleted some variables because we are hard to find some of the data, and we add extra column, which is successful. This one is indicated how this case was publicly perceived as a success or failure. And here's the dataset overview. We focus in the Australia market, so we find 76 Australia cases and 1 cases is in New Zealand. And among those, there are 39 failed cases and 38 successful cases. And first, I will visualize the distribution of time index and cost index. As we can see, if the index lower, usually successful cases have a lower index. And also, we done the visualization of other response variables and to validate the response variables that we choose, because usually they are performed better among those successful cases. And here is we also conduct the 2-sample t-test, try to validate the exploratory features that we choose. And we can see with lower p-value, they play significant difference between 2 groups. So they suggest they can be a very important factor in determining the project outcomes. And I also do the 2-sample test using different kind of categories to further validate the both response variables and the exploratory variables. And there are top 10 variables keep consistently playing part role among different categorization. And now we'll go to the modeling part.
Thanks, Robin. With Robin's finding, we are going to the modeling. Robin find significant features, so we use all the features to use that data, and we do the pre-processing. We employ the significant feature, and we just split the data into the training site and test that into 80% and 20%. And we try to use 5 modeling. The first one is logistic regression. It's our baseline. It's just what looks like the linear regression, but it's different. It's use a curve to tell us which is the success and which is failure. And then we try to use the decision tree. You can see that it's like a route. If you choose that route, each station will give you a result. And after that result, we just go to the end and let us know what happened. And then we try to use the SVM. Here, it's just 2 sides. In the middle, it's like a river. We try to make the result in both each side to decide which side it is. Then we try to use a random forest. It's like multiple decision trees, but we got several results. After result, every result will vote. We get the voting and get the result from the voting. The last, we try to use XG boost. It looks like the random forest, but it doesn't, because the random forest will vote. But here, every result will affect the rest of the result, and we got the only result from there. With all this modeling, we get the value. All the value here, the much closer to 1, it's successful it is. The accuracy is that how successful we are, and the processing is how much missing value we get. The less missing, we get higher value, and the recall means the less mistake. The less mistake we got, the higher mark. The F1 score is the mean of these two, and the area and the ROC curve is like the higher value close to 1, the two sides failure and successful, we can get significant. You can see that we are lucky. We got the value and also XGBoost is 1. Maybe so it's over the side we got. Maybe it is. It is the most useful thing we got, right? And with our interest vending, we just see which the most important feature from the XGBoost. That's it. Here's Sharon's turn.
Hi everyone. I will talk about the automation and improvement part. So first one, I will start with the automation.
Yeah, 2 minutes.
Oh yeah. And why we use automation method is because these reasons and how we use it. We just explore the attribute model from the model we built, and then we just feed it with our new data. You can see the code here, and then if it's 1, then it's successful. And here is the output here. And then we also do some improvements because I want to combine all these traditional methods into one new method, which is failure index. And here is the calculate. As we can see, the higher the value is, the more unhealthy the project is. So I try to find some linear relationship between the different features, and then we can see the R square is kind of close to 1. So we can say here is a linear relationship. And by running this model, we can have some guidance and the resource allocation. And here is one thing good to know. By running my model, we can see that the most unhealthy project that the model assumes is not in NT. So now I will pass it to my online teammate Henry.
Yeah, we have one online teammate.
Yeah.
Henry?
Hi.
Hello.
Hi everyone.
Please.
Let's talk about the limitation briefly.
Can you speak louder, please?
Yeah. Is that okay?
Can you try again?
Hello?
Yeah.
Yeah. Okay. Now. Can someone?
Yep.
And the left
Go on.
side. Sorry. Let's talk about sample size. For this case, the sample size is too small. We only selected 77 failed and successful projects. May not represent the whole picture of tendency prediction. The next is data collection. For data collection, we have to make sure the data consistency and quality. Moreover, not all causes failure might be available or quantifiable in the provided data. The next one is visualization. IT projects can vary in nature, size, and scope. So determining which features are more relevant for predicting failure is very challenging. Furthermore, some data might be qualitative, which needs to be transformed into numerical values suitable for machine learning. Next slide, please. The next one is predictive limitations. while the machine learning model can predict the likelihood of failure based on historical data, it cannot guarantee future outcomes. New challenges and environments might arise. The last one is generalization. Since we only choose Australian IT projects, patterns might not apply to projects in other countries due to some differences. That's all for our presentation. Thank you. Thank you for listening.
All right, I really want to congratulate the Data Wizards on a really engaging presentation, and your excitement just comes out into the room. That was a really great part of your presentation.
Thank you.
In one of the measures that you put in there was project quality, I think.
Yeah.
And I just want to find out from you what that was made up of when you were building that measure.
The project quality is put in the response variable part, because we try to like define the project failure like from our side instead of like just like publicly perceived. So the quality one, because we actually also do the manually collecting part, and we go through each cases and try to like identify, because we got the performance metrics.
Yeah.
And each of us, so with the help, somehow from here is the performance metrics. We try to give the data from our side because it's very clear, because usually project quality will depend on like how user perceive. For example, take the Victoria Mikey cases. They said the response time is longer and there's always errors. So based on this one, we will give the quality as well, because it's definitely not meeting the quality standards. Also, because we need to go through 70 cases, or even more than 70 cases, so we also use some help from data from AI. If we can't get the exact like very accurate like government documents, then we probably need some help through AI to like go through all the website and see what's the quality number for this one. Also, we give this metrics to AI as well, so we'll compare both like from our side and the AI.
Yeah, great. Does your team have a view of what you could do with this model next, like how you could take that forward?
We can just, as I just explained, we explore the model, which is attribute because it has the most accuracy. So we can like feed this model with our new data, because every project must have like estimated cost, estimated time, and we can just assume every project is very healthy. So we can score them with 5 at the beginning. So as the project goes, like this scores will like decrease time by time. So we can just use the model to like rescale them once again. Then we can know if this project will like have more probability to be successful or be failed.
Yeah, and we also have another idea, because with these listed features, it's actually easier from government to put in those data. So if we can, like for example, ask like when they doing the planning, ask them to give the score for each features, and we can like establish a data set, for example, that will be more practical for government.
Yes, in Australia, just want to try to do the automation that we will develop application that each step you just enter the value and you can predict how are we going.
Yeah, so through the process going, we can also doing the predict as well, not only like at the beginning of the project.
Great, thank you. Other questions?
Not a question, just a comment from me. I particularly like your legislative alignment rate. That's well done.
Thank you.
From a lawyer, I'm particularly happy to see it. Thank you.
You mentioned the outcome was based on public perception of success and failure. How did you collect that?
Because like when we're doing the research, we just like search like, for example, on Google like successful cases and failed cases. And it's funny, like some cases actually is conflict, because some people think it's successful and some may not. So we just based on the like most commonly perception of that.
And frankly speaking, at the very beginning, we do use AI to help us.
You go back to the modeling.
Yep. Which one you want to mention? XGBoost? Yep. This one? Yep.
If you choose two of the models from here,
yep.
Which two you want to choose?
XGBoost is first one, but in my opinion, I will choose the decentralized tree. But the value here doesn't support me. I don't know why.
What do you think of why the XGBoost is 100%?
Of course, it's not 100%. It's just in case there's a moment. But it is true because each decision, each result will affect the others. That means it's not just like a butterfly impact, that everything will impact the others. Like if we employ less people here, it will affect our cost, our time, everything will affect by them.
You change some parameters for the XGBoost?
Which one? XGBoost. This one.
Yeah, you change some parameters.
Actually, we just use XGBoost like it's the original one, but how?
We didn't actually change the parameter.
No, we didn't change it.
We don't have the time like
yep.
to read them every time, so we just like run through everything. Like
frankly speaking, we just use the random state to fix it. Yep. But yeah, we try, when we find the value is 1, we try to use some different case to test it, but it's still 1.
We also like try to.
So it looks like it's efficient.
Yeah, also because we already got our fixed data set. So apart from this data set, we also try to collect extra data and try to go through the XGBoost model. And most of them are successful, like based on how they publicly perceive.
Even last night, we do discuss about the value 1. Yeah. Is that suitable for this one? But it is our result. We won't change it. Thanks.
Thank you very much.
Right, the next presentation is the last presentation before the break. Right, I'm happy to advise that we are ahead of the time, so hopefully we can finish all the presentation early. The next team is Data Science 4G. Is Data Science 4G here? Okay. Okay, so can I confirm there's no data science? Anyone representing Data Science 4G here? No, that's yeah. they did submit some solution stuff, so right. So if that's the case, we will probably go ahead with the break early. If that's okay. But before that, let's take one big group photo with everyone as well as the judges. Tracy, would you like to advise us how we should arrange this?
Some of the insights have been quite fascinating. Yeah. Often we have gut feel and experiences of what to make a project succeed. So
All participants. Yeah, I'd like to invite everyone to come forward. Let's arrange ourselves. Maybe the judges.
You are in the center?
Come on, everyone.
I think we need to sway a little bit. Three, two, one more. Three, two, one. Three, two,
Okay. Yeah, right.
Oh,
Any slide? Yeah.
I didn't see this.
So we're gonna be back up.
10 minutes, yeah. Yeah. We'll resume in 10 minutes. Yeah. Oops, sorry. After this, we are the ones, right? No, yours is 4. Number 4.
Okay. Final.
Final. Yep. Okay. Yes. Yep. All right. All right. Okay.
Thank you.
Yep.
Can we take photo with you?
Yeah, of course. Thank you.
I actually refer a lot to your lectures. Like I also get a lot of statistics analysis and all the like.
That's good. That's good. That's what we want to see. That you guys actually use some of the things that.
Yeah. You're like, yeah, it's a solution that we can refer in the lecture. And it's really good.
That's okay. No worries.
Yes, so we started by so we and we spend a lot of time to data and of course it's not the new, so of course we
So in the actual lab, the business so do you are in charge of all that?
No, I'm not in charge of the innovation challenge. It's Cherry. Yeah.
So can I keep the camera?
The mic or the camera? Camera is coming from that. So there's no issue with the camera.
Okay.
Okay, so
Yeah.
we still can keep that one.
Yeah, of course, yeah.
That one.
So I think mic, I can lend this mic, but you have to return it to me after the event, because it can capture the voice quite well.
Yeah, all right.
Yeah. This laptop that comes from here.
Okay.
Do you need this or not?
What's that?
No, this is just multiple USBs.
Oh, I don't.
Yeah, okay, then I will just take this away.
Yeah.
Right.
That's all.
Yes, right.
I actually can just keep these two and then I return both to you. Is that
Yeah, I think we can just keep the setup. If you need this as well, I will also probably just hang around in the afternoon. Yeah, right.
So, I wonder. This is my I need to apply for that.
Yeah, so
You know,
Yeah, no, like somehow I use some kind of like
This is not actually. So normally I
对，我给切了，我看见了，我说换个圈儿。哦，还是什么图上？进出名了。对，就是从选员那直接开始高，选员一上来就高，见不高。我对不起选员了，我在那鼻子呀这儿不够了，直接我觉得我不能来找。然后直接让人家，我们衔接不了拿一个芯片。
Just a quick check. Is the one here? The team called the one? The one. Is there any team by the name the one here? Because I haven't got any slides.我们应该掌握一些正式应该把它片条。不想。
不，好玩的前提是人家那一晚上给他挠出来了，一后边网就完了。这事儿人家明天不带你，我俩又不来了。你跟他们我俩没有
Hey, how are you? So you previously.
我跟 YY 加上一个人300块。
Who's the next one?
你还给我摆个号号在这儿呢。
So
Do you miss Singapore? So convenient. It's really so safe, right? Very
You guys collected it out. I just made a lot. 我跟你照片是个人儿啊。特明显了，对不起啊，我问你算胖子里边儿。不是真的。
I would refrain from any comment. Not nice. No, it's not. It doesn't mean that it's something like this. I don't see it.
This year is better than last year. Like presentation wise.
Em nghĩ là nhỏ có thể em nhớ là ở cái công ty có mà thầy có thể
So they will come like there was there.
Because it's
It could be anything. Okay. So yeah, actually was easier last year. Look, like you have to what check the photo.
It was easy in the sense of
yeah.
You need to decide
But
what to do.
Yeah, we have to do. But what happened this year?
Like, this year is more challenging.
There's like
Where's the data? What to do with the data?
You're like 300 pages report for one project. I'm like, no.
All right. Yes, you can. Yes. It's working. It's working. Yeah. You wanna try now? No, not yet.
Yes, thank you.
Okay. So we'd like to invite everyone to be back to their seats. We're going to start in 1 minute. So I hope everyone enjoyed the break. Now we'd like to continue with the next team, which is the Insight Seeker. Oh.
Hello everyone, we are Insight Seeker and my name is Zero and this is Jenga. Today we'll discuss our analysis result on IT project failures. Our analysis is divided into two parts. The first examines the various factors leading to project failures, and the second one shows just how we use machine learning to predict the success or failure of future projects. Before diving into the analysis, the fundamental challenge we met was collecting relevant data set. And to address this problem, we used the web scraping to extract data from why do projects fail. It is a great website, including globally noteworthy troubled problems. And the structured layout enables us to use Python to automatically restructure the information into a structured data set. So because this website includes all kinds of projects, so we want to focus only on the IT projects, so we used keywords to filter all the IT-related case studies. So finally, we got 88 robust IT-related cases, and you can see the transformation from raw web data to our structured information here. Our next task was to organize the failure factors into 7 categories like team, stakeholders, resource planning, and so on. And these categorizations is based on the literature about the IT project failure factors. And for example, maybe it's too small, but you can see that the factors related to collaboration, communication, of course, team fell under team, and the factors related to stakeholder, user, customer, clients, and so on, they fell under the stakeholder. This systematic approach resulted in a structured tabular data set we used in the analysis following. So once organized, this data set has unveiled clear patterns and insights. First, we visualized the frequency of each category and found out which factors were most commonly associated with the project failures. And for example, from this bar chart, we can see that we need to focus on the control and project manager and the plannings most to avoid future failure. And additionally, we try to understand how these factors interact with each other. So we mapped the frequency of factor pairs using a co-occurrence matrix and visualized them using a network graph. For example, there's a strong interconnection between control, project manager, and resource. Yeah, this one's the controls, project management, and resource. We can see that it illustrates that the project manager's control is closely tied to the resource management. And additionally, we attempt to group the failure factors based on shared characteristics using k-means clustering. This heat map offers a compelling narrative of these clusters. We can see that the first cluster is cluster 0. It represents the project that faced complexity with a value of 1, and which in turn might have led to planning and project management problem. Yeah, while insights are very helpful, but our main focus is to predict success or failure of future projects. But before modeling, we needed to balance data set. There's a significant skew towards the unsuccessful project now because we haven't included any successful examples yet. But there is a challenge to collect these successful ID project examples. So we actually artificially generated 88 successful project samples by random marking 1 or 2 failure factors at present. This data will be used as an initial step, setting our model for future real-world success examples. And we used random forest classifiers as the previous groups, and we used 70% of the data set as the training set and 30% as the testing set. Let's look at the result now, and we can see that all the performance metrics seems pretty good. They are all above 90%, and though there's room for improvement, but it still can be served as a stepping stone toward proactive risk analysis in IT projects. And in conclusion, our analytical journey provided a dual perspective. One is a deep understanding of the factors leading to project failure, and the other one is a predictive model. And for the next step, we can enrich our data set and refine the model for the real-world application. Yeah. That's for our presentation, and we are open to discussion.
Thank you very much for your presentation. That was a great insight into how you went about that. I just wanted to check what factors or what led you to choose the random forest classifier as the model that you used.
Yeah, because we searched several literature about the IT project failure, and most of the literature all used random forest and has great result. And it is very commonly used for classifying, and we have many dimensions, so it's good for our case. So we just decided to use random forest.
Great, thank you.
It was great to see that you were using synthetic data to generate the successful results. Did you run into any issues with the synthetic data?
Yeah, because we tried several ways to generate this synthetic data. At first, we just wanted to mark all of the successful data as one. We wanted to mark the unfailed factors. Yeah, failed factors with -1 and the successful factors using 1. And we want to mark all of the columns with one for successful data, but it doesn't make sense because we don't need any models to predict. So we then used, we randomly just generated some synthetic data, but it doesn't make any sense. So we just thinking by randomly marking 1 or 2 columns, it just like our real life projects. The project won't be perfect with only 1 or 2 failure factors. It will still success. So we just generated the synthetic data like this one.
Already coded very well. Just one question regarding the futures. When we consider machine learning, we need to make sure each future is independent with others. But one of the futures is a schedule holder, and the other one is a project manager. From my understanding, the project manager should be one of the schedule holder. How can you explain more about that?
Yeah, because project manager, of course, belongs to the stakeholders, but it has more influence in the project than the other, like clients or the head of other people and something like that. So we just separate them. And according to our results, the project managers has a great influence in the project. So yeah, I don't know if this.
So your
yeah.
schedule holder is just a users
It's basically it's the client and users, and yeah, because there's contribution factors, and they already concluded these contribution factors. And if there's a stakeholder, there's a word stakeholder, client, user, we just take it as stakeholder.
Another one is for keywords.
Yeah.
You just create some of the keywords.
Yep.
According to the search.
Yep.
What are you going to improve for the keywords?
Yeah, because the categories are based on the literature, but the keywords inside the categories are decided by ourselves. So we can do more research about this one and make the keywords more accurate and let the categorization more precise. Thank you very much.
All right, thank you.
Thank you very much.
Coming up next are the IT ladies. PowerPoint or PDN?
Yeah.
PowerPoint. This is the one, right? The
Yeah.
V6.
Yeah.
Just right here. Yeah.
Good morning, everyone. Thank you for joining us for today. So our presentation about predictive analysis and decision making for government IT project. And we have the insight from high profile failures. We are IT lady, and we're excited to share our insight with you. So this is the agenda for today, and I will start with an overview. And I will start with an overview of failed IT project in Australia. So according to Grab Private Market Research 2017, Australia is facing with challenges in IT project with major project fail and cancellation. And as you see in the screen, the first key figure, for every $1 billion spent, a weightage of $108 million is observed. And for the second figure, you can see that a significant 65% project fail at the initialization stage. And finally, 18% project cancellation before its completion. So the figure highlight a critical need for a predictive analysis model to cope this failure. After analyzing various failed IT projects, and we found out we have identified some common pattern contribute to the failed IT project. In the middle, you can see. So the most common thing is the project not meet the requirements, so it's failed. And the other factor like poor project planning, poor quality management, poor risk monitoring are the factor contribute to failed IT. And besides, you can see inadequate coordination of resources, governance issue, and staff shortfall also contribute to the failed IT. At the beginning, we approach with the first method. We do the data collection manually. We look up to the government website, non-government website, and we find out the data, and we spend a lot of time. So based on the common factor, we define which we need to collect the data. We have the project detail like project name, IT provider, and time laboratories, performance metrics, and the issue and gap. However, we spend a lot of time, but we just collect 59 failed projects and 17 success projects. Even that, we cannot collect all the data we need. So that's why we come up with the second method. That my colleagues will continue with that. Yeah.
Thank you. And I have mentioned about the method 1. And method 1 has it is a semi-automatic manual data search. It means we use manual, but use some of the AI tools to build the data. And it has a lot of disadvantage. The one thing is it is inefficiency, and it will make a lot of mistakes. And the data feature sometimes was built on a subjective judgment. That means we use a paper and then judgment. Maybe this judgment will depend on the different person. It will be different. And a lot of data may not found. So we just briefly use AI to generate data. The AI we choose is Google Bard AI because it is, good for search for the internet data. And I will talk about this map. It is very important in our process. The step 1 is we use AI data collection to collect data. And we put 3 important files into this AI tool. One of the files measuring features, and the other is scoring data, and the other is the project name we list randomly, and we put it in the AI Bard AI, the Google Bard AI. It will search from the internet data to give us data set, and then we use data clean to prepare, and then we use these tools and build a predict model. Let's talk about the feature selecting first. I will talk about how we select these features. This is a result of our feature selecting. You can say it's characterized in 5 different ways. One of is basic feature. The basic feature is not used to measure. It's just for the information of this project, and the IT and testing, and planning and management, and budget and time. The last one is outcomes. We measure the outcomes in the different ways. The first is delay of the year and out of budget. But some of the projects are out of budget, but finally the outcome is good. Also, the stakeholders evaluation. We use this one to importantly to. Oh, I'm sorry.
I paused the time, no worries.
Jakob, every 1 hour 15 minutes.
Okay. It switches by itself after a while.
Don't ask me why, but that's how it goes. But then you come back.
Maybe I need some relaxed time.
Take some break.
Yeah, yeah. Good.
Okay, it's back.
3, 2, 1.
Welcome back to the story. Okay, so the outcome we use like five important features. I think user adoption is really important for a project, but this data we cannot find on Google. So to be mentioned, so our feature is built in the field cases. We have analysis before and the project lifestyle. I will talk it later. And the basic feature, the gray ones, not for evaluation, and the blue features must need a scoring rule. I will talk it about later. So our feature selecting is most built on the field project analysis and this project cycle. We will get through the project cycle, life cycle, and to see some of the, we just extract all the important measurement from this cycle, and we ask questions about, can this feature be compared between projects, and can the variable be characterized, and can the variable be ordinate, and is the feature important to the project life cycle, and can the feature be obtained, and then we extract the result features. So how about scoring the rules? Because we use logistic models, so we need to translate these features into numbers. Just for example, we like project planning approach, we from the poor to rich, we will give them numbers to 1 to 4. And to the project management approach, we because it is really different, so we give these features the scores. Then we will come to the data analysis part. From AI, we just got 200 cases, and you know, Google AI, they just gave me one time maybe 10 cases, but it's really good. And we get 200 cases and from 4 countries, and there are 83 failure projects and 16 successful project. Then we will go to this data set and data clean preparation. Okay, this is a data clean preparation. We're using map rules. It's like map, you just know it's a map. And in this map, it will give you ideas of which feature, which variable will give what kind of score. And we translate all the variables into numbers. And then is the result of the logistic regression model. You don't need to know the details about it, but the accuracy is 0.92, so it is reliable. Yeah, it's built on the data we get, and you can say I just use outcome as a target variable, and the result is user feedback, risk management, and test method, and also out of budget, scope adherence, and the stakeholder involvement is really influential to this result. Okay, then this figure can show you can just show directly what is influential, the influential of the outcomes. Yeah, I'm sorry. Yeah, the longest bar is the influential features. Yeah, and we use user feedback for the target variable, and it is really interesting. The test method is really influential to the user feedback, because if the test method is really poor, and user will not satisfied with it. And also the out budget target variables. And the delay, it's interesting, the duration is longer and the delay will be longer.
Yeah, and also we found the countries, the stakeholder involvement and complexity and technology is different from countries. Yeah, the advantage of this method is results seems reliable because I have mentioned, and it is a good way to test the model, but they also have a lot of limitations like data security problem because we search for the government projects and sometimes we cannot get the data from the government report because it is security and data reliable is also have this side of problem because the data was all come from the internet and some of the important values cannot found and decrease the accuracy of the model. So this is my favorite part, I think. Yeah, build in the experience of our data science. So we have some ideas of build a decision-making system for the government IT project. We recommend we need to have a survey at the key project milestone, not for the end of the project because we are predict. Right? I'm sorry. Can I have this, Matt?
Okay, thank you. Look, I really want to thank you. That was a fantastic presentation. I know you ran out of time, but what I thought was really great was that your team acknowledged while you were going through that some of the limitations with the data you were collecting, and you were trying to address those limitations by doing more work, which is a fantastic way to grow and improve your projects. As you were getting results out of the model and analysing them, did you have any things that you learned that were a surprise that you weren't expecting? Like, were there things that you were thinking would happen one way, but the data showed that there was something else going on?
One thing is about the difference of the countries. I didn't saw the countries' IT projects is really different because some of the IT projects is really similar in different countries because I choose USA, UK, Germany, and Australia. Yeah. But for the same projects, the result is different. Yeah, it's lumpy. Yeah.
Great, thank you. Other questions?
Great to see you using a regression model. Did you have any issues with kind of translating the output of that model to whether it's going to be over budget by a little bit or a lot, or whether the satisfaction is going to be a little bit or a lot? Because you can give a number.
Yeah, it's really because the scoring measurement is really built on our a briefly measurement. So I just recommend the last one because I just put a little bit on this. So we give the last solution is we recommend government to build internal search engine and an internal project database. And we just collect data from in the process of the project. We have survey on the stakeholders and the project members and also the user feedback. And we all put this structured data into this database. Then we can get enough data to build the model. And if the model will like the different features, we can also change the data connection. And then we can have the decision maker. Do we need to stop this project early, or what can we change this project? And we also make a survey. You can just scan it for the stakeholders and also for the touch users.
Yeah. So you mentioned a lot about the latest reason.
Yeah.
Why you are choosing that model, not choose the random forest or design chain?
Yeah, actually based on what we investigate on the article. So you see in the second slide, we have the common common pattern in failed IT project, and we based on that to build the feature that we want to use in our model. Yeah, we didn't do the randomly. Yeah, we based on the knowledge we know in the existing resources. Yeah.
So you're thinking the logistical regulation is better than the
No, actually, I think it is because of the limitation of the time.
Yeah, because of limitation of the time, we don't have enough time to build another model. So if you see on the course, we have the simple code to run the logistics regression model. So, and then after we submit the code and we find out, oh, our data is poor. We don't have enough information and the model we run is not good enough. So we think, so for the second approach, like the filter work, we want to do to improve our project.
So with 59 failed projects and 17 successful, what advice would you give the government and all other stakeholders in there?
Yeah, this one is the first data we collect. We have both government projects and non-government projects. Yeah.
So with your analysis, did you come up with any ideas on what you would tell the government to make sure they create more successful projects?
Yes, you just saw.
I think we can see the
decision making.
Yeah. See this. Like the output budget, outcomes out of budget, and the risk management. So risk management is really important for the project success. We just manage risk. There are different approaches to manage the risk, and also the test method. Some failure projects, they just don't think about the test method, or the test coverage is really poor, so it will lead the. So I think in the process of the project, if we just find the problem really early, then we can think how to change change these important features. Yeah.
Thank you.
Yeah. Thank you.
Next, we welcome Ray and Jack. Okay.
Hi everybody. We're glad to be here, and thank you IT CodeFair for the opportunity to present our ideas, and thank you Josh for your time. And this is my teammate Ray, and I'm Jack, hence the name, Ray and Jack. And we're here to showcase our key findings for the challenge. So, as we all know, there's no 100% success rate in a real-world scenario, right? But what if there's a model that can prevent from the failing rate rising, right? Let me explain why it's crucial to have a model that can prevent project failing. Right? Today, our team examined government-funded projects that aims to benefit the society. It's implemented to make our life easier and more efficient. However, if the project fails, that means the money that the government invested is wasted, right? So let me give you an example. So we have the three major IT fail IT projects: the robot debt scheme, the Queensland Health Payroll System, and Victoria Miki Smart Card. Right. So the total cost of these projects range around $3.7 to $4 billion throughout the year. So for this challenge, we collected data from various government projects to identify which variables might be the key factor to failure. We selected projects from different government departments, such as law and justice, health and education department. Our model includes 11 variables to determine which are the key factors. The purpose of this model is to predict whether a project is likely to succeed or fail. All right. If we can forecast a project's future, wouldn't that save the government billions of dollars? Right. So here's we'll go through the basic overview of the projects that we have observed. We will talk about the initiation stage, project at risk, project failure, and potential savings in terms of money. So the first one we'll talk about is in 65% of the projects failed when it's in the initiation stage. And it may due to various reasons, such as like the complexity of the project or management tools, or maybe lack of flexibility. Furthermore, if a project encounters trouble before reaching 15% of the completion of a project, it's likely that it will fail. So, and why is this important? Because if the government knows that, all right, the projects fail between those area, like this period, then the government can just withdraw the funding that seems, likely to fail, right? So within this area, 15% of completion of the project, it should have effective execution, during that period. And 90% of the projects fail due to poor planning and poor management within the project. And as I mentioned earlier, billions of dollars has gone to waste because of failed projects, right? A report shows that Australian government invested in projects and wasted at a rate much higher than global average. Let me give you a few examples. For example, Europe wasted 131 million per billion they invested. For China and Middle East, they wasted 82 millions. For India, they wasted 73 millions. And globally, the global average waste was 97 million per billion invested, whereas in Australia it's $108 million, right? If we can predict the outcome and save even 1% of that 108 million, it will be around $1.8 million, right? That's still a large sum of money. So later we will have Ray to tell us what we have accomplished in using Python. Yes.
And here comes the machine learning part. And the model we use in Python is called logistical regression. It's really classical, and it's to predict success or failure, either 1 or 0. It's unlike the linear regression, you predict a certain number. Then a logistical regression is to predict it's a category, like 0 or 1. That's all we need. From the data we obtain, we can see there's multiple variable comes along, maybe like weird one, like project ID. Maybe it's lucky number, who knows? Because I can never reject a number set before come to conclusion. So that's why we have some weird one. And then, of course, money play a big part. Maybe less funded project tend to success, or maybe highly funded like to success, who knows? So money play a big part. In the report that the Victoria government published, they use different colors to represent plans. Like, for example, the solid plan represent green, and they have like a reasonable, kind of questionable concern. They use yellow, and they use red for some sketchy plans for the management. It's interesting to use it. It's important. It's come along again later. We found government report from Queensland and Victoria. I'll later explain why. Because they have published them online. It contains many department government projects that include one that fails, complete, and ongoing. And so it comes with idea of missing data, how we deal with the data, because like there's some missing data. We're not going to put missing data in the machine learning because you just cannot take it. So we use the simplest way to deal with missing data, just drop all of them for accuracy. So at the end, after we drop all of them, we still have 33 data sets we can work on. It comes less sample, but more accuracy. So we prefer more accuracy, more narrow, more niche field, just for the model. We have written automation for that, because at the beginning we had to search a report manually. Like already there's 300 pages for like one project. That's like a lot of work, no way. So at the end we build an automation, and then we'll come out with 256 projects, and then we clean it at the end. So it helps a lot. And the result of the pattern actually shows we have 86% of accuracy. It's kind of decent. It's okay. So I can conclude that the model is fairly decent. And the variable we found is most impact, which is cost and plan management, of course.
2 more minutes.
And we can connect back to what Jackie said. In every billion investment in IT project is in Australia. It's $108 million waste. If we are able to predict with a project with this model, that's like $80 million. That's a lot. And if we are able to use that money for some other project, that's way better for everyone, for government, for Australia, and for the society. So it just really nice for us. To come to the end, the only thing I concern about this model is because our data is from the government, so we cannot really do much with the non-government model. However, if we have more data sets, for example, from non-government, then we can train the model better. It's more, it's not as limited to government. But yeah, aside, because we're focusing on narrow, more accuracy, only for the government, so we can which at least we save the biggest part of the money. Yeah, and that's it.
Yeah. Thank you.
Thank you very much for your presentation, and I really like that you reflected the opportunity to save money as part of that preventing projects from moving into failure. I think what I heard with your presentation was that the investment size was one of the factors in project success or failure.
Yeah, the cost.
The cost. What were some of the other factors that your model came up with in terms of possible risk of project failure?
The biggest part, of course, comes with the plan management. That's the biggest part, and also with time period, of course. And the weird one, lucky number, project number. Yeah, but it's not the biggest part. So at the end, we come down with cost and plan management. Okay.
Yeah, like I said earlier, it's like they have to have effective execution within that 15% completion of the project period, right?
Yeah.
If they fail, then it will fail. Yeah.
And was that 15%? Did that come from your model, or did that come from your research?
It was research. Yeah.
That was my question. Exactly that 15% comes from literature. Who is the author? Or?
Oh, we have a reference, right?
Yeah, we do. Those reference. Yeah, from a report.
So I might have missed it, but what was the value you're predicting? Just whether it was going to fail or going to succeed? Or
Yes. Yeah, that's it. Success or fail. 0 or 1.
Yeah, I got some questions. Last key. Why you're choosing the logistic regression?
Yes. Why use the?
Why we use the logic regression? Because that's the one best fit, suitable for predicting success or fail. Like I said, 0 or 1 category. Like that's all we need for this project. More efficient.
You tried other algorithms?
No, it's just like because by researching, by reading report, I found that logical regression comes to the first place for this project, which is best fit.
So regarding the final variables in fund, is that include the size?
Yes, cost and plan management.
Include the project number?
What do you mean putting the number?
Project ID,
Sorry?
Project ID was just, it was irrelevant. It was irrelevant.
Yeah, we dropped it at the end. No, we didn't use it at the end. It's just for fun.
Yeah.
It's just for testing. Actually, just any other questions? Actually, there's one more thing I want to mention because I thought you were going to ask about the data. It's just interesting. I found that in Australia, we only have 2 provinces. Queensland and Victoria was published with IT open data. And supposedly New South Wales, they have it, but I didn't find it. They started with 2017, and which US started way earlier. And just, I think there's a lot more we can grow in the government. It's just interesting. I find that. Yeah.
And this is
Fun fact.
the data that we found in the ID dashboard from the government. It's like they show a green, which is like, yep, it's going, or it's going like, and then yellow is like, all right, there's some concern, they will monitor like closely, or red is like, oh, they either postpone or they failed or completed.
Yeah, from my career. Yeah.
That's it.
Yeah, thank you.
Thank you.
Up next, we have territory data solution.
Hey everyone, I'm Arsh, and here are my teammates Param and Alicia, and we are here going to present you some key insights that we found on why IT projects fail. We have included the projects not only in Australia, but we have also analyzed the projects and the data from outside Australia, that is worldwide. And yeah, and our vision is to just empower positive transformation by harnessing the power of open data and driving innovation in enterprises, especially the government. And so basically, this is one of the key insights that we found early and this is one of the rudimentary insights that we found, is that it's too much failure. Like 66.7% of the projects worldwide fail, and only 33% succeed. And of that number, 70% of IT projects fail to meet digital transformation objectives that they set prior to commencing the project. And exactly how many projects are we talking about worldwide? It's 33,000 projects worldwide. So that is quite a huge number, and we have a huge potential to actually minimize this number and actually save a lot of money and public resources. And okay, where does Australia stand? 65 to 85% of IT projects fail to meet objectives, and the average cost overrun being often to over 70%. So that's a quite huge number. And these are the major challenges that we found. And as you can see, the major problem that we face is the project management and the leadership thing. This is one of the major problems that is contributing to the failure of this project. The project management and leadership, if we want to narrow it down, and by this we mean that project management approach and project life cycle. So project being run not only as a success or failure, but whole project management life cycle. So Q1, Q2, Q3, Q4. What is exactly the status of the project in that particular quarter, what exactly insights are actually being delivered to the key stakeholders that are making decisions, whether to actually progress the project in the next quarter or not, whether to cut funding or not. So this is one of the most significant insight that we got. And I would like to invite Alicia to actually give some insights on what is the data mining strategy that we used. Oh, and sorry, sorry. And this is how we collected the data. So there were like a lot of data, and we wanted to automate this thing. So what we use, that there are a lot of websites that are providing a lot of the data, and we use web scraping, and we use Selenium, that is an automation testing framework from Python. It's a Python library, and we used to automate the scraping of the website and getting the data. So firstly, we had really unstructured data that we wrote a custom hard-code Python script that will actually convert that particular data into nominal, some meaningful data, but not exactly, we cannot consider that as clean data. But we have a good start point using this web scraping and using Selenium and a few other Python hard coding functions. So this is how we collected the data, and I would like to invite Alicia.
So, firstly, in order to collect the data set, we use the government data. We use the Victoria government data to collect the data of IT project, but we have put a certain criteria to select the IT project, and that is the IT project needs to be greater than $1 million. So once we get the data, we have the raw data that has 395 projects and 29 features. So after getting the raw data, we went through the process of data engineering. While doing the data engineering, we have to do some of the process like data cleaning, and we need to add certain features in it. After doing the engineering data, the project has been 284 project and some of the features had been added. So the from 29 features, we have certain more features and it's like 31 features. While talking about the data set, like there are two most important features in our data set, and that is one of the features is like what are the quarterly, what are the there are in the data sets, the data is like 2022 and 2023, the Victoria government data. In those data sets, the data is divided into quarter. So in those features, we just need to select what are the quarterly data we have, and the other one is the stage. uh, so in this stage, we will be knowing which IT project is in which stage. Either it is in the initial stage, deployment stage, or the project has been success or failure. So CRISDM. So this is the methodology that we have used in our process, which stands for Cross Industry Standard Process for Data Mining, and it is a base for the data science process. So these are the 6 steps that we have been gone through. So the first is the business understanding, and then we went through some of the data understanding and data preparation. In data modeling, we use some of the algorithms, and in the evaluation process, we went to testing the data sets, how the data will be once the testing is done, and at the end is the deployment. Exploratory analysis. So while doing the exploratory analysis, we first check the general structure of the data, how the data will look like. So for that, we need to look how the data set is. So firstly, we just check the few rows of the data, and we check the data type, whether the data type is in the float, object, or the string. Some of the data has this, so in the data series, there are some of the column that has space. So we need to remove the space from the column to make it more organized. So for the data cleaning, my friend Param will be.
So we went for a step-by-step process for cleaning the data. Initially, we cleaned out all of the labels so that it's identifiable by Python, and we converted all of the currencies to float. Initially, all of the currencies that we'd received through scraping, they had dollar signs and comma signs in them. We removed all of that. We removed all of the any values from the cache related columns because we thought that they will be important features. And we replaced them with 0, assuming that that there was a delay in funding from the government in those particular projects. Then we converted the date features in the datetime format, which were earlier in object format, and it wasn't doing anything for our program. We converted the currencies to float, and we removed all of the rows that contained more than 6 NaN values. For the feature engineering, what we did was initially all of the quarters that we had, they had statuses in green, amber, and red. We converted all of them into numerical values, giving them 0, 1, 2 statuses, and the NaN values were given an alternate number, which was 4. We just chose 4. Then we went on to creating new columns where so we saw that inside the data set there was the initiation date, and then there was a revised initiation date. So which we assumed that meant that the initiation of the project was delayed. So we created an initiation delayed column, which was 0 if it was delayed and 1 if it wasn't delayed. Similarly, we created columns for whether the delivery start was delayed, whether the delivery end was delayed, and then we gave the government domains, we gave them a code as well.
2 minutes.
Cool. So this was the final data that we received after all. Here are the some key data insights we saw from the data that we had from the Victorian government, that a hybrid project management methodology of Prince2 and Agile is used the most. Then is Prince2, and then is basic Agile. Here are some insights from the quarterly performance of the projects. So we saw that whenever the initiation was delayed, there are about 16 projects that are already in red status from the first quarter. Whereas if the delivery start was delayed, the projects remained mostly in green or amber status, but they eventually went into red status by the time they reached eventual quarters. This just shows what are the primary public domains, government domains where the projects are being held. Health was where the most of the ICD projects are being held. Because we thought that project management methodology could be a reason why projects are failing, we conducted some experiments, which was a hypothesis test using chi-square, and we did receive some considerable results where we saw we took two approaches, where we took the last quarter where the projects were assessed, and in that quarter, if the project was in red, we considered it to be a failure. And in the second case, if the stage was
Anyway, we would just like to say that the accuracy that we got, final accuracy, was 98% from
yeah,
this data.
from our models.
Yeah.
Great, thank you for walking us through in great amount of detail what you did. And I'm really quite fascinated that that you included the project methodology as one of the factors that you measured. In terms of where you got the project up to, what were the common factors that your data and your model found were leading to project failure?
So we were getting here.
Yep.
So these are, we found that these are the important features that are leading to project failures. In this, as I mentioned earlier, the final status of the status in the last quarter, that where the project was evaluated, that acted like the most important feature. Then project ID can obviously be ignored, and delivery cost difference was one of the key features. So if there was a delivery cost that was already decided, and finally the delivery cost had exceeded its previous value, this was a feature that that was also important. And then was the planned delivery cost. If the planned delivery cost was quite high, that also led to that was also an important feature that in our models.
Thank you.
Really impressive. With 66% projects failing globally.
We received those numbers from a standards report from 2020.
Did you include the project ID in the model training?
Yes, we did.
That was actually, it was a time crunch moment, and
yeah,
some of the things that we actually overlooked.
I honestly realized that like it was 10 minutes before the time that we had to deliver, we had to submit a project, and while I was creating the supporting documents, I realized that I included that, and I thought that it would be unfair if I made a change while presenting.
Yes, so in here, look at the first futures is Q1 22 to 23. Are you consider to combine the Q1 22 23, Q2 22 23? I mean, combine all of the.
Yep. So that was exactly our next plan. But the problem that we faced was because I got sick. The team was actually like I got sick. So that was actually my part to do. Like it was, we wanted to combine all of the quarters into one thing, one column, and we wanted to decide if that particular quarter is actually having a significant impact into the particular project success or failure. So that was one of the feature engineering that was supposed to be done, but it was
no, but all of the projects, they had different statuses in all of the quarters. Like even if we consider Q1 21-22, quarter one of 21-22, and then we go to quarter two of 21-22, the status had already changed. Some had gone from green to amber. Some had also gone from red to amber. So we wanted to consider all of the quarters individually and see whether whether while the project is moving towards its different stages, whether that is affecting the status of the project, whether it's failing or it's moving towards success.
Yeah. Another question is in your data sets, one of the features is called the reverse elimination cost, and that cost is the reverse delivery cost is much higher than the reverse elimination cost.
Yes.
It's 23 times. Can you explain more about that?
So we saw that in a lot of the cases, in a lot of the projects, the delivery cost was zero. The initiation cost was zero. So we assumed that there was a delay in providing the funding by the government, or either there was a delay in clarification from the government whether the project is a go or not. Also, one of the insights that we did not include here was in some cases we saw that the project's case was delivered in 2011 or 2010, and finally the project was initialized in 2021. So there was a big gap between the starting of the project and when the project was actually proposed to the government.
I really liked it how you did the industries.
Yeah.
That was really nice.
Which one?
The industries, health industry.
Yeah, the different domains of that.
Thank you.
10 marks for this.
Thank you very much.
Thank you.
So I just want to check one more time. Is the team called The One here? No. Okay. So judges, we've come to the final presentation. So we're supposed to have two, but one member from the team called The One wrote to me that she's a mother, so the child went sick last night. So I think that's one reason they couldn't. So we're welcoming the last presenter for today, the Buffaloes.
Hello, my name is Lu. My name is Qing Yuan, and today we will talk about our shortest IT projects that we ever worked on time, on budget, in scope, but failure or success depending on. Our topic today is high-profile IT project failures. As you might know, IT projects are beneficial in our daily life in terms of cost saving and increasing productivity. But sometimes when they go wrong, the effects can be felt far and wrong. In Australia, many of these projects didn't unfold as expected, costing billions of dollars, time and efforts for many people, as well as considerable public attention. For example, if you may have heard of the robot debt system, it was meant to be a smarter way for the governments to handle debts. However, it
made algorithmic mistakes that caused financial distress and frustration for many people about debt they didn't owe.
And Queensland Health Payroll Project is another nightmare because things headaches for many workers because of their payment errors.
And let's not forget about the Mighty Smart Card in Victoria, which was expected to be a seamless transportation payment solution. However, it launched in 2009, had more pumps than a roller coaster.
The examples remind us that starting a big tech project is one thing, but making sure it's worked properly and smoothly is a whole different ball game.
Given that challenge, we aim to discover the hidden reasons behind the setbacks for the projects. Do they share a common thread? Are there repeated patterns of mistakes?
And how about success story? What does the divergence happen?
And ultimately, we're keen to discover if the outcomes for the projects can be predicted, or are they just always a roll of the dice?
So we took deep dive into our projects, both here in Australia and internationally, seeking the answers to our questions, and here is how we conducted our experiment. First, we gathered data from various research and articles, focusing on repeated information. And then we clean up the data, pre-process it, and select the more features that most useful to our predictions.
With all that said, we then use different machine learning algorithms to build our classification models, aiming to predict whether a project is a success or a failure. And then we evaluated our models with different accuracy metrics.
And similar to other data science projects, gathering and preparing the data also pose greater challenges for us. So we would like to give you more detail about these phases. First, we began our search for IT projects through channels like research paper, government audit report, and news articles. And for each project, we focus on key elements like time frame, budget, main purpose, success, or failure factors. And we also spotted on the way the recurring keywords like overtime, over budget, user issues, poor governance, poor leadership during this collection phase. It also helped us to pinpoint the commonalities across projects. And at the end of this stage, a total of 56 projects together with their details were collected.
Collection, we prepare our data before modeling, and we apply our professional judgment as well as utilizing statistical and machine learning methods to transform these raw observations into meaningful features. For example, with categorical features, we input values such as yes, no, and unidentified. For numerical features, there are some substantial gaps between the projects. For example, with budget and the actual cost. So to reduce the gap, we try to convert these features into another feature that are more meaningful for our project. For example, with original budget and the cost, we combine them and calculated the over budget scale to reduce the gap, and it will be more meaningful for our modeling later. So in total, we have 13 meaningful features, can be falling into 3 groups: time and budget, which combine features such as representation time or active years of a project, people and skill, containing features such as number of key agencies involved, whether the project has a stakeholder or IT issue. And we also look at additional factors such as the country, the success metric count, and the project main purpose.
In the exploratory data analysis, I will avoid to analyze median, mean, some statistical metrics, because to be honest, our data set is small. It cannot be a representative of the whole population, so you cannot apply it to the real world. So I will talk about the obvious trend that we can see between our projects. Is that project didn't go so well only, so many projects failures have a problem with keeping things on time, on budget. And there were also issues with getting every work body on board, and technical problems. In particular, we find that users are primarily involved at the front end stage. So that less they have limited engagement throughout the entire process. So this raises the question that during the testing phase, how their feedback or user experience were incorporated or taken into account. Similarly with IT issues. Sometimes I think with MyGov ID, our projects, we think we already spotted IT issues during the testing phase. But sometimes maybe the sample tests are not good enough, or we not properly address it or adequately rectify it before launching, so it still causes many problems. So unlike successful cases like Estonian e-government or Korean e-procurement, when taking into when it comes to stakeholder and IT issues, they have a different approach by ensuring end users were always actively engaged at every step, and they try to make sure that relevant stakeholders were well equipped with necessary knowledge, so they can have a seamlessly transitions into the new platform. So another interesting observation that we notice is for a majority of our problematic projects, they do not revolve around replacing or upgrades of the current system, but about building an entirely new system or platform. So it might appear that starting from scratch comes with its own sets of problems. So we should pay more attention. To these projects in the future. As for the results of our modeling, we implemented with different machine learning algorithms, and the accuracy score ranged from 75 to 92% highest with random forest classifier. And also we perform hyperparameter tuning to optimize our models. However, because our data set is small, it might not be meaningful now, but we believe that this can be scalable when we collect more data in the future. Looking closer into the random forest, we can see that's the most predictive powers is reserved when predicting failure project and success project. And primary factor influencing the likelihood of being failure are stakeholder issues, complexity, over budgets, over time, and technologies. In conclusion, those results open doors for many promising future work. However, there are some limitations in our project. Small data set, restricted access to valuable information because the project elements are kept confidential. And we know that 75% of our projects are failure. So this imbalance can affect our data analysis and model performance. We also identify some outliers during our reprocessing phase. They can be influentials, skewing our result, and maybe reveals a unique pattern. So without a clear understanding of how they affect with our model performance, we chose to retain them for more comprehensive analysis later. However, like with every other project, there are lessons learned, and it's the same for us with this project. And it's captured in one simple yet powerful word: scoot. In English, it means to go or leave someplace quickly. But in our project management context, we realize that it has an entire new meaning. It stands for stakeholder issue, complexity issue, over budget, over time, and technology issue. So next time you are managing an IT project and these elements are present in your project, so it's time that it means that you are navigating the thin line between a project success and project failure, and it's a sign to stop and reassess. That comes to the end of our presentation today, and we do have a question for you. Thank you. So we would like to ask a question that so throughout our research, we realized that there are like many lessons learned captured. They seem the first IT project failed,
So we're just wondering if in the government or in your company, if there's a special team that working on these kind of analysis of past project failures, so that because you have access to more valuable data, and this is all the data that we can find on the search only. So we just think that with access to more valuable data, then more like meaningful analysis and the issues can be identified better. So yeah.
Thank you. So in answer to your question, before I ask my questions, we do have teams who are recording the reasons for project success and the challenges of a project, and if a project didn't succeed, reporting why it didn't succeed. But often they end up as reports and things that get written about, and then they're made available to a project manager in the future to read all those reports, which is actually the challenge, and why we thought it would be great to take that from a report and very time consuming to consume down to data models for project managers to self-assess their projects. And so I think I really like that you've created Scoot. I think that's a really smart approach. Turning that into something that project managers can talk about and think about is a really good and very smart next step in your data analysis that you were doing. So well done.
Thank you.
I was really fascinated with the graph and the analysis you've done around the project implementation. The pie chart. Did any of your modelling or analysis start to compare the Scoot outcomes with that project implementation goals? Was there any, you talked a little bit about some insights you had about the difference between a build versus a replace and upgrade. But did you do any analysis of each of those different categories and was Scoot outcomes?
Actually, this one is about over time, over budget, stakeholder, and technology. So, just like S O O T. How was the complexity?
Yeah, we miss complexity.
We miss complexity,
which is like additional factors that can influence the project success or failures. Yeah. So that's for future work we will do, I guess. Yes.
Great, thank you. Well done.
Fantastic. Same. I will join my fellow judge in stating, yeah, this is really useful. And so basically, if we take a lesson, we have to be particularly careful when we are starting the new project, and we are in something is very complex, and we have a lot of stakeholders. Like a previous team, did you look at the industries or not really?
Actually, we have the categories about domain.
Yes. Yeah. So domain is when we So domain knowledge is when we record the what is the domain knowledge that is required to build that system or to run this IT project. For example,
like business, healthcare, payroll checks. It's not about IT skill only. You have the knowledge about accounting, finance.
Yes.
Yes.
With the Rolodex system as well. Yeah. Yeah. So we record that in this one.
Yeah. Fantastic. Well done.
Question around the models. You had so many models that you go at. With the hyperparameter tuning, did you use the automated hyperparameter tuning to try and streamline?
So I use just a set of hyperparameter. I guess just a normal one. Because we actually just do that as an extra to see whether there can be any improvement. But the highest one is still 91%. I think with random forest. So we think that is actually because of our small data set and also other limitation, like we need to apply professional judgment when we deal with the missing data. So we believe that will be more like scalable when we have more data.
Sorry, same question with Brand. Another question is, data is come from manually?
Yes, we collect. Yeah.
So, okay. So, what will the future work you guys want to do?
Future
to,
work.
to implement the model or edit?
Yes. So we do. I did try to do web scripting on the catalogs of the catastrophe website. And also, but we think that with the manual collection, because many of the details lie in the reports. Like when we think about the stakeholder issue, IT issue, we have to read through it to record all of the information. So that's how we collect our data and come up with the features. But we think that in the future, we want to collect more data also by using other automatic approach, because that will help us to do more like meaningful analysis. Because anything to add?
There's one more thing interesting note about that one. When we're doing our research, is that when we're looking at government IT projects, we found the successful cases, they focus on end users. They try to provide some like personal incentives, like the case of Estonian governments or Singapore. They try to incorporate their government app with another app from the private sectors or from other things that make people find it convenient for them to for daily transactions or business transactions. So they find it's normal way to deal with government applications. So not a reluctant way to do it. So it helped them to be more successful than other governments.
Interesting.
Yeah.
Thank you very much. That was
Thank you.
So that marks the end of a series of very excellent presentations. I'd like to acknowledge the most important people in this room, which are all the participants. So thank you so much for challenging yourself. So you deserve a big round of applause. Yeah, judges, a lot of them had to juggle between final exams, assessment, and this working on this extra project. So they really deserve this big round of applause. And I also noticed that a number of people, Bowen, Kenny, and Liam himself, they were previous participants in the past two challenges. And Liam was our first winner, first round winner. Bowen was our second round winner. So thank you so much for coming back and supporting. So before I invite Brad to just give a closing remark to all participants, so I'm sure that I think judges will have a hard time to decide who the two winners are. So I want to invite all participants to attend the CDU IT Code Fair this Friday. So we will announce the winners. So who knows your team is one of those. Right. So IT Code Fair starts at 9 at DoubleTree by Hilton Hotel at Esplanade. We also want to cordially invite judges, if you have the time, do drop by at this event. And finally, thank you, Don and the team at the NT government for suggesting this very interesting problem statement this year. So we see a lot of different solutions. Thank you so much. So I'd like to pass the time to Brad, probably just to give a closing remark for us.
Thanks, everyone. It's been fantastic to see your solutions that you presented. It's really awesome to see the different ways you've approached kind of the topic. Fantastic to see all the different types of models being used, although I'm sad that no one used an LGBM model. It's my favorite. I'm very partial to it. No, it's really good. It's kind of a new field, so it's hard to work on kind of things that people have done previously with things like machine learning. Where programming, someone's done it before. Lots of kind of things to find and info to help with getting to the solution. Where AI, typically maybe one or two people have done something before, so it's really building something new, trying new things, getting out of your comfort zone to tackle a problem from a different perspective. And the things that you guys put together is fantastic. Like, it's really good to see. I will kind of preface everything with 90% of machine learning is data preparation and collection. And I'm assuming most of you people know that now. Cleansing, prep, standardizing, that's a lot of what goes into machine learning. It's the most important thing you can do. The algorithm itself, it's down on the scale of priorities, and hyperparameter tuning is also the same. They're important, but getting the right data, collecting the right data, clean data is super important. So hopefully things like this will encourage projects to start recording data in a more concise and useful manner, because I really want to see improvements in projects and less overspend and delivered on time. It's always going to be very important, and projects like this are going to be instrumental in helping that happen. So thank you everyone for your participation. It's been fantastic.
So finally, I would like to thank the CDU IT Code Fair team for supporting today's event. Take note that there will be lunch served maybe around 12 shortly in this room. But at the moment, we want to give enough space. We want to give some space for the judges to just finalize the results and probably have a little bit of discussions. So we'd like to invite all participants as well as the IT Code Fair team, probably just to leave the room for a bit. Yeah, thank you. Yeah, I'll be here. No, it's not. Is there any other way you can get it? Later. Yes. Thank you. Sure.